Hey, this is Math 7, Unit 6, Lesson 12, solving problems about percent increase or decrease. So percent increase or percent decrease. The first one, we'll let you do that one there. That's a review from the lesson today. The track team is trying to reduce their time for relay race. First, they reduced their time by 2.1 minutes. That's going down. Then they're able to reduce that time by 1/10. If their final time is 3.96 minutes, what was their beginning time? So we're looking for the beginning time, which means we're going to try to start here and then work our way back up to where it was. It was more than that before. Okay, so you have a number bigger than 3.96 as a solution. So just keep that in mind. Let's look over here. When a store had sold 60% of the t-shirts that were on display, they brought out another 22 t-shirts from the stockroom. If that gave them 84 t-shirts on display, how many t-shirts were on display originally? Okay, so whatever they had, they sold 60%, which meant that what was left? Well, 100 minus 60 meant that what remained on the shelf was 40%. So we know that 40% of whatever they started with, so 40% of, let's just do X for the original amount, okay, what we don't know, was on display. 40% was left, plus the 22 that were added to the display, and that meant that it had a total of 84 there. So 40%, I can't leave it at that. I need to make that a decimal. That becomes 0.40 times x plus 22 equals 84. I can subtract 22 from both sides. So 0.4x, and I can just do 4, I don't need 40, equals 62. We divide both sides by 0.4, and we find out that 0.4 goes into 662. Move the decimal 1, which means move this one over one more, and put it up on top right away. 4 goes into 6 one time, subtract. 4 goes into 22 5 times, subtract, and 4 goes into 25 times. So we find out that x equals 155. So how many shirts were on display originally? 155 shirts were on display originally, because that was my value for x. Number 3 is a great one. It says Claire started an exercise program. On the second day, she ran 10 miles longer than on the first day. So this is called day 1, x. And on day 2, she did x plus 10 more, right? 10 minutes longer than the first day. Here's day 1. Here's day 1 plus 10 more. And then on the third day, she increased her running time from day 2 by 20%. So what does that mean? It means we're going to do whatever day 2 is, we're going to increase it by 20%. Now, again, when I increase by 20%, I'm going to take whatever day 2 was, which is x plus 10, I want to keep all of that, and I want to increase it by 20%, which means I need to do all of it, 100% of it, plus the 20%. So I'm going to multiply it by 1.2. That's the key thing there. I don't want only 20% of it. I want the whole thing. I want 100% of the second day plus 20% more. So a total of 120%. And as a decimal, that's 1.2. That's where I got the number from. And then it says in the end, and ran for 54 minutes. Okay. So she started a new program. On the second day, she ran 10 minutes longer than the first day. Third day, she increased her running time by from day 2 by 20% and ran for 54 minutes. Okay, so I guess the question here is, here's the question. As I'm thinking about this here, the way it's written, it almost looks like I might want to think about what this is by itself, but I don't think that is accurate. In fact, I'm almost positive it's not accurate. I did it a different way before. I want to make sure this is not going to mess us up a little bit there. Minus 10, 35. Okay, so double checking real quick. If I did 35 and I did 45 and I did 45% times 45 times 1.2 would be 54. Okay. It just depends on how you read this last sentence. She increased her running time from day 2 by 20% and ran for 54 minutes. Okay, so I think what this is reading as here, I'm reading it the second or third time here, is that actually I don't need to worry about this, okay? Because what it's saying is that I'm going to take day, on the third day, I'm going to do 120% of the second day, and that means she ran 54 minutes. I'm going to use that number there. If I do that, and I divide both sides by 1.2, 1.2, I'm left with x plus 10 equals, in this case here, 45. 54 divided by 1.2 is 45. If I subtract 10 from both sides, then x equals 35. And that would mean on day 1, she ran 35 minutes. On day 2, she did 35 plus 10, which is 45. And then on day 3, she did 20% more. That's 1.2 times 45, which equals 54, which matches that right there. So that's what I think we would do. And again, this is my second time looking through it. I was starting to do it a different way before, but reading it a second time, that's what that would be. I think if it said that she had run a total of 54 minutes, then we would do what I was doing initially. But it just said on third day is 54 minutes for the third day. It doesn't say a total of 54 minutes of all 3 days combined. So I think that's a better solution there for x equals 35. That makes a little more sense. Number 4. Elena and her family went to a carnival. Elena spent half her money on rides. This sounds familiar, right? Okay. Which I think we did yesterday, it sounds like, I think, with Noah and Diego. She then spent $3 on snacks. In the day, she had $2 remaining. The equation half d minus 3 equals 2 represents this situation. How much did Elena bring to a fair? And again, this looks just like yesterday on lesson 11. We did a problem here where Diego went to the fair number 3, and we had the same type of equation here where it was, in this case, they did a half, and we worked that out there. So look back at number 3 for how you did that one, but you can use this and go ahead and solve. Number 5, the last one here, I believe, for this one. Oh no, it's 2 pages, sorry. Another page. It says four friends, each have a bag with an equal amount of candy in it. Good job. So they had some candy. X. Each friend is then given 4 more, plus 4 more pieces. If the 4 friends have a combined total of 32 pieces of candy, how many pieces of candy X did they originally have? So what do we have as a picture? We have 4 friends. 1, 2, 3, and 4. Everybody started with X, 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 and X, and they got 4 more each, plus 4, plus 4, plus 4, plus 4, and they had a combined 32 pieces. So if I write that down as an equation, what do I have? I have 4 groups of X plus 4 equals 32. Here are my 4 groups of X plus 4 equaling my total of 32. From there, you can solve that, right? We can either divide both sides by 4 or distribute. Let's divide it, go ahead, since we're there. So that equals 8. Subtract 4, so X equals 4. And we're good there. Alright, let's look at the back side. The back side are review questions from the previous units, so let's see how you do. It says a floor plan was drawn using a scale of 1 centimeter equals 2.5 feet. Alright, in the floor plan you have 8 centimeters by 10 centimeters. What's the actual area? So we need to convert these centimeters back into feet. So if 1 equals 2.5, what does 8 equal? Well, we take 8 and we multiply it by 2.5, which is going to be equal to 20. Then we'll take the 2.5 and multiply it by 10, and that's going to equal 25 feet. So in terms of what we actually have, it's not 8 centimeters by 10 centimeters, it's 20 by 25, and the area is going to multiply those together. So 25 times 20 is equal to 500 square feet. Alright, number 7. In 24 minutes, Lynn can run 12 laps around the track. Consider the number of laps she can run per minute. Laps per minute, right? So we're going to look at constant proportionality, find that, and then write an equation. So let's set up a little table. We have minutes, and we have laps, like this. And we put it this way because we're doing laps per minute, so our constant proportionality is going to be laps over minutes. That's our k value. Remember, this is our x, this is our y, and k is always equal to y over x. And what we're given is, in 24 minutes, she did 12 laps. So what is 12 over 24? What? Something's a little backwards there. 12 over 24? I don't know. So we're going to do, in this case here, so our constant proportionality becomes a half, like that. So, so 12 times a half gets you there. So we know that to do one lap, for example, one lap, if we divide it by 12, takes her 2 minutes. Okay, so now as an equation is y equals constant proportionality times x. So we're going to say y equals 1/2 of x. If we're doing it based on laps per minute, making laps the y and minute the x. Something like that. Hope I got that right. Sometimes I get them flipped around a little bit. That's okay. No problem. 8. We have a composite figure. We have a square and half a circle. We want to find the area. So the area of the square is going to be 6 times 6, which is going to be 36. But the area of the circle is going to be found by the formula pi r squared, but I only want half of it because I'm only having half the circle. So in this case here, half of that, radius is 3. 3 squared is 9. So we have 9 over 2 pi plus 36. Not sure if you should leave it like that or not. That's what I don't know. So 9 over 2 is 4.5, or 4.5. So if I did 4.5 times 3.14, I end up with 14.13. That seems weird. No. Let's take a look here. Double check. So 3.14 times 4.5 equals, 14.13. All right. Yeah, okay. And then, yeah, I get it now. So then we add that to the 36. Here, 3, 1, 10 carry the 1, 50. So we'd say 50.13 feet squared is our solution there. Number 9, the last one here. It says write an equation represents the situation. We're all solving for y. So y, is equal to what part of x? We can see that it gets y is larger than x. So y is going to be more than 1. Okay, it's already greater than one of the x's. But there's got to be a little bit more that we have to add on to that because it has already that much of the x done. And then we can see that a whole x is equal to 1, 2, 3, 4, 5. So we have 1, 2. We have 2 out of the 5 right here. So we have 1 and 2/5. Well, I don't see a 1 and 2/5 as a fraction anywhere. Do you know what 2/5 is as a decimal? Well, 2/5 is the decimal. If you were to think this through a little bit, it's going to be actually equal to, well, you could do a fraction if you want to. You want to divide it with a calculator. 2 divided by 5 is equal to 0.4. Okay, equals to 0.40. So with the 1 and 0.4, we're talking about this is going to be 1.4x. That's what we're looking at. And where do we see that? We see that right there. This becomes 0.2, 0.2. So the value of y is equal to 1 whole x plus these 0.2s. So it's good to visually be able to see where we get those numbers from and why the other ones just don't quite make sense. All right, that's it for today. Have a great day, and we'll see you next time.